After finishing the model creation part, running experiment on two algorithms, one is linear regression and second one is random forest regression, I find that random forest regression is working better and its prediction error is far less than linear regression. Then I choose random forest regression to build the model. Here is the web app I have created with Streamlit. Now let me first demonstrate the web app, what it actually is doing, how to use it. Then I will walk through the code. Now this is the complete web app. User can open this app by the link of the deployment. Then user can predict the how much the car price by giving almost 8 information. Now the first information the user have to put that how much the car has driven. If I hover to my mouse, in this question mark, it will say how much the car has driven. So let me give some information. The car, let's suppose car has driven 200 miles, and then it asks me enter the volume of the car engine. If I go mouse over here, enter the volume of the engine. Okay, so let me enter the volume, like it can be 2.6, and then it's asking me enter the year when the car was manufactured. So let me say that the car was manufactured in 2022, and now it's asking me the body type of the car. Let me choose this randomly, sedan, and then it's asking me the brand of the car. Okay, let me choose BMW. After choosing the BMW, now it's asking me enter the model for BMW. So this one is changing. If you notice that if you change the car brand from here to BMW to Audi, now it's asking me enter the car model for Audi. So now these model things are filtered. It's not all the 312 models are here. It's get filtered by the its corresponding brand. So let me enter. I don't know anything. Let's just randomly choose any one model A4. I don't know anything about it. Okay. Now enter the engine fuel type. Okay. In which gas the car is run. Okay. So let's suppose car is run petrol, and the car have registration. The car have registration or not. Okay. So let me choose the car have registration. Now after giving the information, now I have to click on the click button. Now after the click button, this is showing me the predicted price of the car is $9,163. So this is the web app. Now let me go through the code. This is the entire code for that particular web app. First, I have imported Streamlit, Pandas, NumPy, and JobLib. JobLib is for the loading the model, and Streamlit is the a open source library which can be used for creating web app. It is very flexible. Okay. Now first, I have created some dictionary. These dictionary are come from, if you remember in the model creation part, when I was creating random forest regression, I was saving some, I created some dictionary, and I was saving this dictionary some value when I was encoding the label, encoding the categorical value. Here it is. So this dictionary are this. I have saved this. I was saved this in an extra notepad. Then I paste here, because user are providing some information. User are not providing any kind of numerical value. Like user are providing for categorical value. User are providing categorical information. Like when I have to tell the which car is bad, user not entering any kind of numerical value. They are providing categorical information, but machine learning model will not understand, because car is my model is created based on the based on numerical value. So I have to encode those categorical value into numerical value here also. So for that, this is when user will enter the Audi, the original input will be as 0. So then when the user will enter the car brand is BMW, the original value input value will be 1. So and so on for the other value also. So in this type, I have encoded for the all categorical value like brand, body, engine type, and model. This model dictionary is quite long because there are 312 unique model. So that's why this model dictionary is quite long, because I have to encode all the model name into some numerical form. That's why this is quite long. After creating the dictionary, now this line code is showing the page information. Heading. This heading use car price prediction by, this is the line for this line. Sorry, this line is not, this line is for the tab actually. There If you hover the mouse in the tab, you can see the it's saying the you can see a emoji of car, and it's saying use car price simulation by Shubho. This line is this. Then I have load the dataset. I need to load the dataset here also, because for this brand and model selection, I have filtered. I have give user some features, like when the user will change the brand, the model name will also change corresponding to the particular brand. Like if I to user choose Toyota, then this will also change. Now all the model name only for Toyota will appear here, not all the other model will appear here. For that I have to load the dataset. I will show you later. Now this is the find model of the this is the function I have created. This function is returning a list of the model. How it model is working? This model is working based on this model is actually filtering the model's name. This car is nothing but this data set. This car is it is a pandas data frame. Then the car is giving me the model. This line will return a series. In that series, only when I pass to the brand name on this function, it will match up that brand name for the brand column, and then it will return the particular for those models which are come match with that particular brand. Like if I pass the Audi here, then it will return the all the models for that Audi only, and then it will filter all the models, like, and it will not return the other models for other brands. So that's is the model this function is doing here. Then I have created a function for the loading the model, our machine learning model with random forest. Is done a model, and I have here I have load the model. I save the model as a pickle file, and here it is. Now I have written the header. This is this line. Actually, I have used some HTML tag to make it up in the center position, because Streamlit by default it will all the value will be in the left align, not the center. So for that I have to put some kind of HTML tag here. Now I am creating two layout, like column 1 and column 2, because you can see the two layout here. One layout is giving one information, and second one is giving some other information. So there is not one layout, there is actually two layout in this web app. So for that I have created two layout. Then I am start checking information. First I am taking the mileage. This is the mileage. This is the input text input. It is the number input widget. So here from here user can input any kind of number. This. Then I am taking the year. Year is like from here. Right? Yeah, it is. It's a slider. It's not a enter. So I give the so user can don't need to type anything. User can fraction out the model year, because they are not entering any kind of continuous number. In case of mileage, they have to, maybe some car has driven 145.2, also 100 car sub cars so can be entered around like 100 or 110. So in this type, in this way, so user can, so I give the functionality, user can type number by himself or herself, so you don't need to slide this value. But in case of the year, user can slide, because year only increased by one particular, so user have to choose either 1994 or 1995. So there is no information between 1994 and 1995. So that's why I choose the slider option here. And this you can see that every input widgets have a question mark over here. So when I hover my mouse in here, it's asking me a question. So these are from in this health parameter. Every widget have a health parameter. This is a Streamlit code. This is a health parameter where I can write a string or message. That string or message will appear when the mouse will hover on that particular question mark. This is it. Okay. Now I am taking brand input. Brand is which car the brand is belongs. Like it belongs to Audi, BMW, Toyota, and others. I am taking a select box. Select box are nothing but a option of a brand list. Brand list is kind of here. You can see the brand list here. Here is a brand list. It's a list which contain all the list unique brand name. After taking the brand input, where it go? Brand input, I have to encode the brand. So here now I am taking the original brand will be encoded. The original brand name will be passed on the brand dictionary, and it will return the particular number for that particular brand. Like if, from this brand, where it go, this body dictionary, sorry, not body dictionary, brand list. Here it is. From this particular brand dictionary, it will return the value from corresponding the keys. The key is our brand name on the string name in case our in here, and I will pass the string keys value here, so dictionary can return me the original value. So in the end, I am taking the numerical encoding value, not the original one, because I have to pass the numerical information in the model, so in order to predict the price. So I have do the all the same things for every categorical: engine type, engine volume. Engine type is a float number. Body type also I have done the same thing. Now come to the model. Here for the model selection, I have write 6 elif for every particular model. I have to write the elif function, because when the brand input is equal to OD, like here, when the brand equal to OD, the model name will filter out and it will give me the option only for the OD model. And what is will be returned? This the brand name or OD will be passed through the find model function. The find model function I have created there. As I mentioned earlier, this find model take a input and it will filter out the all the model name for particular brand name. When you so in case of OD, here OD will passed. So this line will return a series of particular that brand model or the OD. This is it. I have done this for all the 6 models: Audi, Renault, Mitsubishi, Toyota, BMW, Mercedes-Benz, and Volkswagen. After that, this is a registration. Registration is a simple, very simple. It's only yes and no. This is it. Now I'm creating an input array, because I have to pass the information as an array, second as a two-dimensional array. So for that, I have represented in the same order as the model is seen in the training time. I have to take care of that. So here pass the in the same order as the model are expecting. Now I have created a predict button. This is a button here, this button. Now if predict means if the predict button was pressed, then this function, this line of code will run. Predict will be a variable which is model for this is our model, and I have passed the predict button and I have passed the input array I have just created here. These things will pass here, and then I have taken care of one things here. If the pred is less than 0, so in case user some input some wrong information and user gets some value with negative, then prediction will be the user. I will give the user prediction. Also, I will give the some information like the input value must be irrelevant. Try again by giving some relevant information, because when user will think that if this model or this web app giving me negative information, so that will make no sense, because nothing can be a negative price. So in that case, I have taken care of that error here. So this will not give me error for the random for this model. It was give me if I choose the linear regression. But also in some case, if user input some in some case bad situation arise, so in that case it will give me this error. So user can think that okay, so he has done some mistake, so user cannot fool the model. So for that I have taken care of this. So user cannot fool. Then I have PD is round. I have rounded return, because by default it will return with the wrong integer by very long up to the point, floating point. So I have taken care and taken the only 3 number after the point. So for that, this round function I have used. Then I am writing something like the predicted price is the price is dollar string. I have to convert this string because it's a numerical form and numerical cannot be added as a string. So I have to pass the string argument Python. So wrap it up and make it a string. Then I am showing a emoji price to make it a little bit beautiful. Then I am writing a code instead of success and write. This write will be passed here, and after predicting the price, it will show me this function. And there is the serial balloon. If you notice that when you are predicting something, some value, like if I give some information here, after predicting the value, it's showing me some balloons, and this price is dollar. This price is coming with the beautiful green box. For that, this I have passed this exterior success, and for that balloons, I am writing this function. So this is it for the model creation. After the model, user can read a little bit about the project. Like here, you can predict the car price by giving score and information like brand model. so user can read what the give what this thing is doing. Actually, I'm not leaving completely blank. Then after that, I am sharing the full project notebook, because user can, or if it's some kind of students like me, they are, if they think that I need to see the code or how you do it. So for that, I am providing the drive link where I will upload the all the code materials for this complete project, and also I am importing the GitHub link for the middle project. So this was the complete part, and this model is completely ready, and this model is completely ready for the deployment. Now let me check that if model is giving me some relevant information or not. Like, let me give some input here. First, I will give some, my one car is drive 4,400 mile, and the car engine volume is 2.5. And then let's suppose input the car was manufactured in 2000 year. Let me fix all of this, because what experiment I am going to do, I am going to check the model, my model is giving me some relevant information or not. Suppose if because these information are varying, because this information will be vary for the price, because if the mile is quite higher, quite larger, then in case the price should be very less, and in case of mile is smaller, in that case price should be less. So I am checking that. Let's first me try to giving the let's suppose the car is drive 4000, has already driven on 400 miles, and car is manufactured in 2000, car body type is sedan. Let me car be brand name is BMW, and whatever it is, let me choose another one. Now I will fix this one, petrol, and the car registration as yes, of course yes. Now let me click the predict button. Now it's giving me the car price is $7,230. Now this is the car price for this information. Now I will check giving some small other information, like I will check only the mileage, like let's suppose the car has drive only 50 mile, and I will keep the all information same. So in here I supposed to get some higher value than 700 and 230. Let's check or it give me that result or not. Yes, this one give me slightly higher value, because I keep only change the mileage column, and I keep all the information same manufacturer year and sedan, and it give me slightly higher value. Let me check with other also. Let me keep the mileage 50 here also, and let me increase the engine volume like 3.5 or 3.6, and let me choose a brand a little bit newer car like 2012 or 2016. Let me choose the car is in 2016. It is quite new car. Let me choose the brand name is Audi, and I don't know anything here. Okay, let me choose here. The car is done on petrol, or I live like also in petrol, and also registration has the car has registration yes. Now I am predicting quite a new car. The car has manufactured in 2016, and car has only driven 50 mile. Car engine volume is also quite high. So now I am expecting little bit quite larger value. Let me check that how much the larger value the model is giving. Yes, it's working fine. Now it gives me almost now the car price will be almost 69,245. Now by this information, like in the car is quite new in 2016 only, the car is only seven sorry, not seven, 5 years old. Also the car engine volume is also, this car price should be higher. So yes, this give me some relevant information. So the model is not working randomly. The price are giving me not complete random. It is give by if I input some relevant information, the price can be a little bit closer to the original price. So yes, my model is working. So this was the entire project. Thank you.